All right, welcome back. So today we're going to continue our discussion about some derivative rules. So the last video was mostly about the power rule, but within there were also those rules about like, hey, what if you're adding two functions or subtracting two functions? And those were pretty intuitive because they're just like, oh, take the derivative of each of them. Well, for the product and quotient rule, unfortunately, they are not super intuitive. So let's look at the product rule to start out with here. So we got f times g. We want to take the derivative of it. And so your gut might sort of go like, so just the derivative of f times the derivative of g. And that would be wrong. So we will actually talk a little bit about why that's the case in class. But so let me just tell you what the derivative rule is. So if you got two functions you're multiplying together, then the rule is to find the derivative of the first thing and multiply it by the second thing. Not the derivative of the second thing, just whatever that function is. And then that's added with the derivative of the second thing times the first thing. So f prime g plus g prime f is the rule there. Okay, and so the quotient rule is similar in that it is not just f prime over g prime. It is a little more complicated, but it's got some of the same structure as what this has here. So f prime times g subtracted by g prime times f, and it is all over the original denominator, g, quantity squared. Okay, so in class we will go over like a visual proof of the product rule, and then later on in homework you'll see a proof of the quotient rule based on the product rule. Since division is just multiplying by a reciprocal, you can sort of use the product rule to help you out there. Okay, so let's go ahead and do a few examples of this down below. So let's look at the first one here. So we're going to differentiate this. Now, note that you probably, if you got this in the wild and you were just wanting to find the derivative, you probably wouldn't use the product rule. The smarter move would be to distribute that t squared so that way you can just use the power rule. But since we're trying to show off what these derivative rules do, we're not going to do that, and we'll do it sort of the longer and probably less smart way of doing it. So here we go. We're going to find the derivative of this function. So f prime of t is equal to. So something I usually like to do is sort of like notice what the two things that are being multiplied together and maybe like mark it up. So like here maybe I put a cloud around the t squared and a box around the 1 plus 7t, just so that way like my brain's like, cool, so that's the first thing, that's the second thing, so like matching them up with the two things up here. All right, so here we go. Using the rule, first I want to find the derivative of t squared, so that is 2t. And then I just want the second thing. I don't want to do anything with it, so 1 plus 7t. And now we're going to add that with, so now the derivative of the second thing. So the derivative of 1 is 0, derivative of 7t is just 7. And then times the second, or the first thing, not doing anything to it. So there you have it. There is the derivative of that. Of course, we can now simplify it if we wanted to, but this video is just to showcase sort of the rules, so we're not going to simplify anything. Okay, let's go ahead and take a look at g now. So g prime of x. So the first thing here is this 3x squared minus 7x plus 9. And then the second thing is this big thing. It's very obvious in this case what the two things are since there are the parentheses, but it was maybe less obvious, that's why I used that. All right, so here we go. So the derivative of the first thing. So using my power rule, I got 6x minus 7 times the second thing. Sorry about that. If I couldn't edit this out, so I got somebody knocking on my door. Okay, so derivative of the first thing times the second thing plus derivative of the second thing. So 3 times 14, 30 plus 42, there we go. X squared plus 16x. Oh boy, I've run out of room here. And then it's going to be times the first thing. So I'm going to just write it underneath here, but it should be next to it. I didn't leave space. There's a John Mulaney joke in here somewhere. Okay, there you go. So that is it. Derivative of the first thing times the second thing plus derivative of the second thing times the first thing. All right. So that's the product rule. And again, like you could simplify this, but why? Next, we'll look at what the quotient rule does for us. So here we want to do derivative of the top times the bottom minus derivative of the bottom times the top all over the bottom squared. Okay, so let's see what we get here. So h prime of x is, so the first derivative of the top is going to be 2x. And then times the bottom, so just 5 minus x, subtracted by the derivative of the bottom. Well, that's just going to be negative 1 times the top, x squared. And that's all divided by the denominator that we originally had squared. There you got it. And again, simplifying can happen, but we're just not going to do it here in this video. All right, so let's see another example here. So this one, we will find dy over dx is equal to derivative of the top. So that's going to be 2x plus 1 times the bottom minus derivative of the bottom, so 3x squared. 6 has a derivative of 0 there, times the top, plus x, all over the denominator squared, boom, like so. So there you go. So that's just applying the rules. This isn't fun, this isn't like exciting, but we're using the rules and just getting used to it. So these were all done sort of like with the equations. Sometimes you don't have the equations. Like we'll see some examples where we just have the graphs of these things and have to try to answer questions like this. Here's an example of where your function is based off of another function and you don't know what it is, you just have maybe a few values to use. Sometimes they even throw them into a table for you. And then we're actually going to evaluate them at specific numbers. So at the end, we won't have x's and t's and stuff like that left over. We're going to come to a value. So let's see what we come up with here. So we're going to find f prime of 4. So the first thing I'm going to think about, oh, that's a mislabel there. That should be capital F, and that should be a capital F. If you were wondering what is little f, that's a good question. Okay, so the first thing I'm going to do actually is find f prime of x. I'm going to think about this just generally and generically, okay? So if we do that, so we're thinking about what is the derivative of x times g of x. So that's a product. So the first thing in my product is the x. The second thing is the g of x. Okay. So derivative of the first thing. Well, the derivative of x is 1. Times the second thing. Well, that's just g. Plus derivative of the second thing. Well, that's just g prime of x. I don't have an equation for it, so I can't like plug in specific formulas here. I just got to throw in this notation. And then times x. Okay. So if like you make that look a little bit prettier, it is g of x plus x times g prime of x. All right, so now we're going to plug in 4. So let's do that. Switching colors here. So we want to find now f prime of 4. Since I've got the formula here, I'll go ahead and just plug it in. So g of 4 plus 4 times g prime of 4. Well, that's where we get this info from the problem here. So we get 2 plus 4 times, and that's -3, the derivative there. So what does that end up being? -10? Cool. And there you have it. So a common mistake that happens sometimes is students will plug in the 4 first and then take the derivative. The problem is every time you plug in a function first, you create a constant and then the derivative would be 0. And these derivatives do not represent just 0 every time. These are not horizontal lines necessarily. So we differentiate and then plug in. Okay, that's always the order. All right, last one. Let's go ahead and do this one here. So slightly different notation, but it means the same thing. So we want to take the derivative of this expression, and then we want to do x equals 4 at the very end there. So let's see here. Let's figure out what we get here. So d over dx of f of x over x plus 1. Okay. So here we go. We're going to go ahead and use the quotient rule here now. So derivative of the top, that is f prime, times the bottom, x plus 1, subtracted by derivative of the bottom, it's just 1, times the top, that's just f, all over x plus 1 quantity squared. Okay. And so we can now, at this point, plug in the things we already should know for this, actually. Oh, actually, let's not do it. Let's just leave it like that. I was about to plug in what g prime was, because we had this big formula here, but that's ridiculous, because we're about to plug in 4, and then once we do that, you'll have f prime of 4, and I've already found that over here, so I was about to make more work for myself. Let's not do that. Okay, so now let's come over here and find this derivative at 4. I don't feel like writing the whole thing again, so I'm just going to write this at x equals 4. So that will be f prime of 4 times 4 plus 1 minus 1 times f of 4, all divided by 4 plus 1 squared. All right, so here we go. F prime of 4 we found in the previous problem. It is -10. We're going to multiply that by 5 minus 1 times f of 4. Okay, we just got to figure that out. So we're going to come back up to the original function, 4 times g of 4, which is 2. All over, and this will be 25 in the denominator. So this will be -50 and -8, so -58 over 25. There you go. Beautiful answer. So there you have it. So we're going to use these rules a lot in class, so make sure that you know them and that you can use them pretty quickly, and we will sort of see what we can do with these things along with the other rules. So you'll notice that as I was going along, I was also using the power rule and the sum and the difference. So we're using those still as we go along here. All right, so please take the survey and come in ready to rock and roll. Thank you.